Hey students, hello. Today we are going to have a demonstration to show the beam with the conjugate beam method. And the beam that we are considering has different cross section, which is very similar to the one that's in the PowerPoint. But in the PowerPoint, the beam is symmetry, but this beam is not, because the load on the left side is 20 kilonewton and the load on the right side is 10 kilonewton. Okay, let's review what they're asking us. They're giving us the simply supported steel beam, and the loading, as I mentioned, is not symmetry, is unsymmetrical load. Unsymmetrical load. That means the deflection going to be unsymmetrical also. And if you consider this, since the load on the left is large and the load on the right is smaller, so the deflection on this side going to have larger slope compared to this side. And then the elastic curve, okay, that we're going to have is going to be have some maximum deflection that's pretty close to the middle of the beam, but not at the midspan, okay, of the beam. It should be somewhere around here. If you assume that the deflection is supposed to be something like what I'm sketching here, that is going to be maximum around here, and then it's going to be returned back to the point D, because this is the pin. It's going to allow rotation of theta A, and this is the roller. It's going to allow the rotation or the slope of theta D, theta D. And the maximum supposed to be somewhere around here, and at the maximum point, at the Vmax, we have what? Very important. We have what? At the maximum, we have the slope, or the theta is going to be 0. That is going to be the maximum maximum deflection, or the lowest point of this. And what else do you have? They give us the moment of inertia of the cross section, which are not equal. This is going to be 2D, 2I, and the other going to be 1I, and each I going to be 210 power 6 millimeter power 4, or if you convert it into meters power 4, it's going to be times 10 minus 6. Okay, you know that already. And also, since the force in kilonewton, the E going to be 210 power 6 kilonewton per square meter. So that's what you already know. And what they ask us to determine the slope at A. So they ask us to determine this. And they also asking us to determine the maximum deflection of the beam. That is going to be this one, okay, with this condition, by using the conjugate beam and all the elastic curve properly. So this is the sketch. And since the beam is not that complicated, the sketch is roughly correct. Okay, so what's the procedure of analysis? First one, we got to what? We got to analyze the beam, to draw the shear diagram, to draw the moment diagram, and after finish this, we're going to draw the conjugate beam, changing the moment diagram into the elastic weight, and then changing the support of the real beam into the support of the conjugate beam. And the last one, we analyze the conjugate beam to determine the slope and the deflection, in which the shear in the conjugate beam going to be the slope, and the moment in the conjugate beam going to be the deflection. Okay, so that's the big 3 steps we should have. Let us start by first one, analysis. Analyze the beam. The beam. For shear diagram and bending moment diagram. Okay, this is a big step. Before we do this, that means we're gonna what? We're gonna draw the free body diagram of this beam, and okay, let's set this reference axis, x and y axis, and we have the beam by let's say 5 meter. Let me scale it up by 1.5 centimeter for 5 meter. That is going to be 1.5, and how much? This is 5. So it's going to be like, okay, 6. Okay, and it's divided by 1.5, and we have the beam here with something who's strengthening it. Actually, in the real application, we may have this kind of beam because they like to reduce. The main thing is you may reduce the Vmax, okay, by reinforcing steel plate. For example, steel plate at the middle portion of the beam. This is some kind of situation. You can reduce this. You can reduce the friction. If you change this problem by taking the 2i into i, you can determine the Vmax also. And if you compare the Vmax from that to Vmax from this, you will see that the Vmax that's calculated from this only one I going to be larger than this. Okay, this is one of example that you may strengthening what's so-called the beam by reinforcing the beam with a kind of steel plate. Okay, and then what we have the 20 kilonewton force here, 20 kilonewton force here, and 10 kilonewton here. Okay, and 10 kilonewton here. And what we have is the reaction that's going to be at the A, since it's a pin, it's going to be A sub Y and also A sub X. Okay, and this one going to be B, this one going to be C, and this one going to be D sub Y. And you got all the length that's required to calculate the reaction. That's it's going to be 5 meter, 10 meter, and 5 meter here. And what we have is just summation of x sub x equal to 0. And then you get a sub x equal to 0 easily. And then you can take the moment for what? Take the moment out here, if you like. Okay, summation of the moment about a equal to 0. And what happened is the d sub y gonna rotate like this, counterclockwise. Okay, and it's going to be d sub y time 20. So we have 20 times d sub y, and it's going to be what? This is going to be counterclockwise. So this is clockwise. So it's going to be equal to 20 times 5 equal to 20, and then times 5. And you also have this 10. This is plus 10 times what? Times this one is 15. So this is 15. This is 250. This is 300. Okay, that is going to be what? Is 20 times 5 is 100, right? This is 100. This is 100. Sorry, this is 150. So this is going to be 250. So you're going to get d sub y equal to 250, and then divided by 20. Okay, and then you will get the d sub y of this one supposed to be 12.5 kilonewton. So this is your d sub y of 12.5 kilonewton. And then now you may have the a sub y, summation of f sub y equal to 0. This one is up. Okay, so your a sub y is going to be up 12.5 going to be up, so it's going to be a sub y plus 12.5. And then what you get is this is upward equal to the downward of 20 plus 10. So this means going to be a sub y equal to what? That's a sub y. This a sub y going to equal to 30. This is 30 minus 12.5. And then you get this for 17.5. This is going to be 17.5 kilonewton. Okay, that is your reaction at the A. Okay, now you are ready. After you get the reaction over here of 12.5, this is going to be 12.5 kilonewton, and this is going to be 17.5 kilonewton. And now we are ready to draw the shear diagram, and then draw the moment diagram, and then we draw the conjugate beam. Okay. Now just move a little bit to here, and what we have is this beam, and let this beam gonna be the shear diagram. So I take this one as the vertical axis of shear kilonewton, and the horizontal, that is going to be x meter, and between this you got to have the C, okay, and the B here, and we have this one is for 0 meter, and this one may be 5 meter, right? This one may be 15 meter, and this one may be 20 meter. And then we have the way to draw the shear diagram, let's say by using the graphical method. Okay, we can draw the shear diagram and M diagram. Okay, we have what? We have rules to draw this. If you like to review it, it's going to be dv by dx equal to minus w, and what v sub b minus v sub a. Let me have this one. V sub b minus v sub a, for example, equal to integration and minus. That is going to be integration of w dx. This is the area, okay, the area of the w between a and b. And the last one, you may have, if we have upward force, delta v is plus. If you have downward force, delta v is minus. So we start by here. We move from the left to the right, and then we have what? We have 17.5. So let's say 17 is about 18. We do the scale of 20. It's like 20 kilonewton per 1 centimeter. Let's say that is going to be, so 18 is about 9 millimeter. So you're going to be up for about 9 millimeter. That is going to be plus 17.5. You need to put the kilonewton because the kilonewton is already here. And then you move past the A, you may see the distributed force is 0, right? When the distributed force is 0, you start coming into this one. The dv by dx is equal to 0. The dv by dx equal to 0. So what we have is, we're going to have constant. This is going to be constant. This is going to be constant. When you are alive here, your shear still plus 17.5. Okay. Now you are at B. When you arrive at B, this one gonna take you for for 20 kilonewton. So that's going to take you down for 20 kilonewton. That's about centimeter, right? That's it's going to be like this. And what we have here is going to be plus 17.5, and you're going to minus 20, and then you're gonna get this for what? For minus 2.5. This is going to be minus 2.5 kilonewton, and it's going to be minus 2.5 kilonewton all the way here, because over here have dv by dx equal to 0. So dv by dx is 0, and then you get around here, you got this. Now you let's see, and then that's going to take you for 10. That's going to take you for 10. 10 is about 5 millimeter. So it's going to be minus 2.5 and then minus 10. That is going to be minus 12.5 kilonewton. So you're going to have this for constant, because the value is 0. So dv by dx is 0. And then from this for minus 12.5, you get this. It's going to take it back here. Okay, that's this. That's your shear diagram. Okay. And next, coming to the moment diagram, and again you get this vertical as the moment is the m kilonewton meter, and the x is going to be x meter here, and this is going to be 0, 5, 15, 20. Okay, and if you may to review this, you have what? You have the dm by dx equal to v. The slope of the moment diagram is equal to shear. So you draw the moment diagram, you go back to the shear diagram. If you draw shear diagram correct, your moment diagram is supposed to be correct. If you draw the shear diagram wrong, for sure, your moment diagram will be wrong. Okay. Next, f sub b minus m sub a. That is going to be the area. Okay. Under v diagram between what? Between a and b. So the difference in the moment is going to be the area under the shear diagram between what? Between the a and b. Okay, and then the last one, you may have your external moment. If you have the moment like this, delta m will be negative, and if you have the m like this, delta m will be positive. Clockwise is positive, counterclockwise is negative. So what you have is there is no moment here. Okay, so this is going to be 0 kilonewton meter at A. It's a pin. Okay, and we have the roller here. This is the roller. Is also 0 kilonewton meter. Is the pin and the roller without the external moment. Okay, and then we first start by what? So we know this 0. We start by this. Because of what? Because shear here is 17.5. Okay, so it's going to be 17.5 all the way here. So this is going to be some kind of a straight line here. So we have the dm by dx equal to plus 17.5. And what the moment here? Moment here is moment m sub b, because m sub b minus m sub a equal to the area here. The area here is going to be what? 17.5 times 5 is going to be 17.5, and then times 5, and you may get the m sub b equal to 17 times 5, 87.5 kilonewton meter. So okay, you got this. Let's say we have 100 kilonewton meter per 1 centimeter. So that's very close to 9 millimeter. So we have this. Okay, and the first part of this is gonna be this one, okay, and you have the slope here, you have the slope here of 17.5. And then you move further into this region, into this region. You got the shear of minus 2.5 all around here. So your dm by dx is going to be this one is going to be equal to minus 2.5. That means, for example, your moment diagram going to be down here. And the moment here is what? You really don't know. Yes, moment here is at point C, m sub c. And this time it's going to be minus here. We got it for what? 87.5. This is 87.5. And this is 87.5. And then it's going to equal to the area here is minus 2.5. And time what? Time 10. Okay, and then you get m sub c equal to, this is minus 25, this is plus 87.5, and then you m sub c gonna be 62.5 kilonewton meter. So you get your m sub c. That is about more than 6 millimeter, just a little bit larger than 6 millimeter, and then you got this. Okay, and now this is gonna be 62.5, and the slope here is gonna be minus 2.5, and this is minus 2.5. Okay, and the later is going to be easy because this is 0, and since the shear here is minus 12.5, so dm by dx going to be minus 12.5, so it's going to be decline from 62.5 to 0. That is our moment diagram, right? Okay, and later we going to draw the conjugate beam. Let me move this one a little bit more. This portion here is not support here, so let me have this one for moment diagram, and to clear the area for the conjugate beam. And next we are going to draw the conjugate beam. Okay, now we finish our part, and second we draw the conjugate beam with what we call elastic wedge. Okay, since I is different, so this elastic wedge will be some kind of need special care of. Okay, we have the beam there, and what we have for the beam is what is the simple beam, and we know that for the drawing for the real beam into the conjugate beam, we got to change something. Just review. If you have like a real beam, this is a real beam, and this is a conjugate beam. Okay, and then for the real beam you have fixed. Okay, conjugate beam you're gonna change it to free end. If you have free here, you're gonna change it to fixed here, and if you have internal support here, you're gonna change to internal hinge here, and then also if you have internal support. Okay, if you have internal hinge here, you got to change to the internal support here. Okay. However, if you have pin, external pin, the conjugate beam still external pin. And if you have external roller, you will have external roller. So this is just the review of it. Okay, if you have, for example, if you have pin, steel pin, and roller, steel roller. Okay, we are going to draw the conjugate beam, and let's also we need to take special care with the segment what BC having two times moment of inertia. Just take note here. So what we have is let me have the conjugate beam here. And now this one, like I said, this is pin, steel pin, and this is A palm, and the roller still be the roller, and this is gonna be D palm, and you have 87.5. Let's say if you measure 100 kilonewton meter, 100 kilonewton meter for 2 centimeter, for example, for about 2 centimeter. This one must be about this. Approximately, that is going to be the elastic weight of this point is going to be 87.5 divided by EI. And if you like, let me zoom this a little bit, so we will have more detail on this. And then we have what? We have this portion of the 2i. So this is gonna reduce by a half. This by half. 87.5 divided by 2 is 43.75. That means we have this portion for only half of this. This is going to be 43.75 divided by EI, half of this, and 62.5, that's about 13 millimeter for this portion. This is going to be 62.5 divided by EI, and we have this portion of the beam having this elastic weight. Elastic weight always point out, as we know that elastic weight M squared EI is in opposite direction of the W. And next, what is here? 62.5 divided by 2 is 31.25. This is 31.25 divided by EI. So it's supposed to be here. Now we have what is called the conjugate beam, and then we have 3 portions of elastic weight. One is the red one, another one is the black one, and the other is the blue one. However, at the middle part, we should separate them into 2 parts. One is going to be this one, and another one going to be that one. Let me pen this one a little bit. This is going to be the yellow one. And this is going to be the orange one. and with this one is the green one, and we are going to determine the what within the resultant of this elastic weight. Okay, this is going to be this, and there are going to be 3 of them. Let me start by taking care of this one first. We're going to have this of and we really know that the distance of this beam, right? Let me move it a little. It's a conjugate beam, and then the distance allowed here is going to be 5 meter, 10 meter, and 5 meter, and this is going to be B palm, this is going to be C palm. And how much for this one? This one going to be 1/2 of what? Of 5, and then 87.5 divided by EI. And then if you push it into your calculator, you're gonna get it's for 218.75 divided by EI. You may pause your video and try to check it out. Okay, it's not that hard to take care of this. 87.5 times 2.5 is 218.75. Okay, and the distance around here is going to be what? This one going to be 2 times 5/3, so it's going to be 10/3. This is going to be 5/3. Okay, and next we have this one. This one, and the distance here and here going to be half of this. This is going to be 5 meter, and this is also going to be 5 meter, and the value of this going to be the area here. That is 10 meter, and time what? Time this height. This height is 31.25 divided by EI. So this is 31.25 divided by EI, and then you're going to get this for 312.5 divided by EI. Okay, that's the second one. The third one is going to be here. Okay, and it's going to be for this one. We taking care of this. That is going to be 1/2 of 10, and the difference between here is 43.75, and it's going to be minus 31.25. So it's going to be 43.75 minus 31.25. That is going to be 12.5. Okay, that is going to be 12.5 over EI. That is going to be 12.5 divided by EI. And then if you push it, it's going to be 12.5 and gonna time 5. Okay, that is going to be 62.5. It's going to be equal to 62.5 divided by EI. Okay, if you like, you make this as the orange, and you may make this one as the yellow, because there are a lot of them, so you won't miss it. And also you can determine the length here. Okay, this is 10. Okay, this is going to be 10 divided by 3, and if you try to calculate this is going to be 20 divided by 3. And the last one we have here, and we are going to have it for this one, and this one is 5 meter, so this is 5/3, and this is 10/3, and this is going to be 1/2 of 5 and time 62.5 over EI. And if you push it into your calculator, that is going to be 2.5 times 62.5. That is going to be 156.25. 156.25 divided by EI. And if you like it, you may push this one in green. So that is your conjugate beam, and now you are ready to determine the slope. Okay, so find the slope theta A, and let me addition for theta B also. So we are going to find both. Both going to be what? Both going to be equivalent to what? Equivalent to D sub y prime. And this one going to equivalent for A sub y prime. So that means we are going to find the reaction that's going to occur on the conjugate beam. And since the picture is very complicated, let draw the reactions on the conjugate beam. Since we have very limited space, if we have more space, we can draw it further. Let me doing this. And what happened is we're going to have this one for D sub y prime, and this is going to be theta sub b. It's going to be theta sub b, and this one going to be A sub y prime. And what should we start first? Let me take the moment about the summation of moment about D prime is going to be equal to 0. So that means the A sub y gonna rotate like this. A sub y gonna rotate like this, and we have A sub y prime. A sub y prime. We have A sub y prime times what? 20 times 20. And what else do we have? All of them gonna rotate in the opposite direction of the A sub y. So just push it into equal to. Equal to what? This one? 218.75 and divided by EI. How far away from that to this? This is going to be 20, and this is going to be 10 over 3. So minus 20 by 10 over 3, you will get this distance. So we gonna minus 20. 20, and then 20 is here. And then minus 10 over 3. Minus 10 over 3. That's the first one. And next, what we have is this one. And this one is what? This one is 62.5. It's gonna rotate in the same direction, plus 62.5 divided by EI. And what is the distance between this one and this one? Let me take a look at this. This is going to be 15, right? 15. This is also 10 over 3. So I just take 15 and minus by this. We got time 15 and then minus 10 over 3. So you got 2 already. How the third? This one is the third. This one is what? This one is 312.5. So we plus 312.5 divided by EI. And the distance from here to here, this is 5 meter and this is 5 meters, so it's gonna times 10. And then the last one we have is this one, so we have is plus 156.25 and then divided by EI. Okay, and then it's gonna times what? This one to this one, 10 over 3, so it's gonna times 10 over 3. And then if you do very careful calculation, that you must do it, you will get the A sub y palm equal to 401.042 divided by EI, and this is going to be theta sub A. Okay, and if you like to compute it in the actually the value of it, you just put this. That is going to be this one, 401.042, and it's going to divide by EI. E is going to be 200 gigapascal. Since the calculation is based on kilonewton, so it's going to times 10 power 6 kilonewton per square meter. And the I you have is 200 and 10 minus 6 meter power 4. Okay, if you put them and then you may cut this and cut this, is just this one divided by 200 and 200. This is going to be 10.02. This is going to be equal to 10.02 and 10 minus 3 and radian. That is going to be the value 10.02 of this, and you also have this as the one that's in the form of equation. And if you like, you also can determine the theta sub d, not theta sub b, sorry, theta sub d. Okay, next we just use the summation of f sub y equal to 0. What we have is downward is positive, so d sub y palm we have d sub y palm is downward, and this one plus 401 plus 042 divided by EI. So 2 of this downward, and this one equal to 218.75 divided by EI. And you also have this plus 62.5 divided by EI. And this one plus 312.5 divided by EI. And the last one you have this plus 156.25 and divided by EI. Okay, so take a good care of this again. You will get the d sub y palm, the force, the reaction d sub y palm equal to if I'm correct, it's going to be 348.958 and then divided by EI. Okay, this is going to be our result. That is going to be theta sub d, the slope at d. You can see the slope at D is smaller than the slope at A as my assumption. What assumption is, since the force near the A is 20 kilonewton, larger than the force near the D, which is 10 kilonewton. So the slope as A is larger than, so it's correct, okay? And then if you put them into your calculator, this is going to be 348.958 and divided by 200 and 200 and 200. You just take this guy out. So you got this of equal to 8.72. This one gonna be 8.72 and 10 minus 3 and radian. Okay, that is show you. And if you take a look at the pictures here, you may see this is going to rotate clockwise. This is going to rotate counterclockwise. So what we have is this is going to rotate clockwise, okay, and the other one going to rotate counterclockwise in the opposite direction. Okay, that's we have for the slope at A and D. Next, we're going to determine we're going to find V max, the maximum deflection. Okay, let me move here and I move here a little bit, do some kind of explanation. And as you may know, the maximum deflection gonna occur about here between B and the midspan of the beam. If we just follow our assumption, and then we may put this thing in the cut like this, and we may say this one is the one that we are going to determine the X. We don't know the position of this yet. That is the position that may produce the Vmax, and it will have this condition, the slope equal to 0, or for the conjugate beam the V palm gonna be 0. So over here the V palm must be 0. So you may use this part to calculate it, or this part to calculate it. It's up to you. Okay, and for me, I'm going to use this portion with the condition of the shear force that occur in this section is going to be 0. Okay, let us consider the free body diagram of this portion of the beam, and let me move this one, and we're gonna zoom it because they are going to have a lot of detailed calculation here. Okay, now we project this down here, and this one here, and this one here, and let me have the conjugate beam. This portion is here. This is going to be A palm, this is going to be B palm, and we also have the reaction here. And if you may recall, that is going to be A sub Y palm. A sub Y palm is going to be this one. Okay, this is going to be 401 point 0.04 0.042. Okay, 401.402, and then divided by EI, and then we have the blue. Okay, that is about this. This is portion of this, and this is going to be 87.5 divided by EI, and we have this one. Okay, and with this one of 218 to 18.75 divided by EI, and you also have this one, the position of it already. That is going to be 10/3, and this is going to be 5/3. And next you have this one, the 43.75, and you have this one for 31.5. So the difference here, you know, that is going to be 43.75 minus this is going to be the difference of this is going to be 12.5 over EI, and this one deducted by this. And what we have is this one going to be the yellow one. Okay, and the distance we are checking here, this is going to be 5 meters, and this is going to be x meter. Okay, and this one is blue, this one going to be the yellow one. And we still have the orange one on top of it. And the problem is, we know this, right? This is 31.25. This is 31.25 divided by EI. But we don't know this, how much is this. But we can determine this by finding over here. This is going to be 12.5 divided by 10, and y divided by this one. This is going to be 10 minus x. Okay, by similar triangle. Okay, and then we have this one for this one 12.5 divided EI. Okay, and then it's going to divide it by 10, 12.5. And it's going to equal to, this is, let's say it's y. It's going to be EI. And then it's going to be what? This is here is what? It's going to be 10 minus x. Okay, it's going to be 10 minus x. And you may cut this and cut this. And then you may expand the equation into 12.5. And gonna time 10 minus x, and it's gonna equal to y times 10. So it's equal to 10y. And if you like, you may have this one for 125. Okay, this one for 125, and this one gonna be, actually you may divide this one, so you may divide this one, just take this one down and divide all of them by 10. So you're going to y equal to, this is going to be 1, this is going to be x divided by 10, so it's going to be 12.5 and minus 1.25x here. Okay, and if you like, you got to divide it by EI. Okay, to get this. Okay, this is going to be the yellow and the orange here. For this one, okay, it's going to be really easy. Okay, this one gonna be height 31.25 divided by EI, and it's gonna time x here, so it's gonna time x here, here, and then over here gonna divide by half. That is gonna be x over 2 and x over 2. And this one, we don't have it. That is going to be 1/2 of x, and then time this, time 12.5 minus 1.25 x, and divided by EI. Right? And then if you do it, that is going to be equal to 1/2 x times this. No, it's going to be 1/2 x, this one plus this one. Okay, so y, this is y must plus one, this one plus this one divided by 2 and times this. Okay, so it's going to plus this one is 12.5 over EI. Okay, that is going to be correct. And then you may get the area, the resultant here of 12.5 x minus 0.625 x squared, and then divided by EI. Okay, is you got like I'm going to have this one, and let us say this one going to be a little bit. You got to taking care of it very well. Okay, before that we're going to find x. If you like to find x, what we do is we're going to summation f sub y equal to 0, because this point the v prime going to be 0. So what we have is this is going to be the m prime, and over here is going to be the v prime. This v prime going to be 0. So let's see, the downward is positive. Okay, and then we have this for v prime plus v prime is downward plus 401.402 divided by EI. It's downward, and then it's going to be up, 3 of them. Okay, this is going to be 218.75 divided by EI. And then this is going to be complicated. This is going to be plus 12.5x divided by EI minus 0.625x squared divided by EI. And the last one here, you're going to plus 31.25x over EI. And then this all going to be equal to 0, in which this one must also be 0. And then you rearrange this. You may cut this. And this one may take to the left. Okay, this one we have 0.625x squared. This one take to the left. And you have this one. This one and this one is going to be plus together. This is going to be this one and this one going to be 43.75 minus 43.75 divided by EI. Okay, take this one out. So and then take this one to minus this is going to be plus. Oh, sorry, EI. We already cut EI. We don't have the EI. this is 401.402 minus this, that is plus 182.292, and this is gonna be equal to 0. Now you must solve this equation, and if you solve it carefully, okay, you may get the x equal to 4.45 meter. So we arrive the x of 4.45 meter, which is less than 5 meter, half of this is 5 meter. Okay, so it's pretty close to here. It's near at the middle. Now we are ready to taking the moment about this point, and then we have summation of the moment, the taking moment about this point equal to 0, and this is going to be positive. So we have m palm rotate this one gonna rotate the same. So follow this, just plus 401.402 divided by EI, and this time is here, this is 4.45, this is 5, so it's gonna time. Okay, that is the first portion of it, and then it's going to be equal to we have much area here, just work if you like, just zoom this out a little bit. Okay, so we will have a little bit area to work on. So take a moment here, this one rotate here, this rotate here, and this one this one is easier. This one is 31.25x divided by EI. It's gonna time what? You time x over half, right? It's gonna time 4.45 and then divided by 2. Okay, and if you like to go further, this one, it's going to be 1 plus 218.75 divided by EI. Okay, EI, this is EI. And going to have what? This one to this one. It's harder. So this is 9.45, and this is 10 over 3. So it's better to just what? 9.45 minus 10 over 3. Okay, that is next. Okay, and the last one, you have this one. This is this one. And the distance from here to here is gonna be what? Gonna be 2x over 3. This is 2x over 3. Okay, and then you're gonna be plus 2x over 3 is gonna be 2 over 3 and time 4.45, and then it's gonna time this one. Okay, just put this one 12.5x divided by EI, and then you minus what? Minus 0.625, and then x squared, okay, divided by EI, and then you got to do it very carefully, and you will get the m palm equal to minus 2036.932 divided by EI. And you may know this is going to be the maximum deflection. And if you like, you just put this into take minus out. It's okay. Take minus out. It's going to be the downward. Okay, it's going to be downward. That's it's going to be 2036.925 and divided by EI. You know that the EI before this is going to be this one, 200, and time 200, and it's going to be in meter, right? That is going to be in meter. It's going to be equal to 0.0509 meter, and then this one is downward, and if you put it into millimeter, that is going to be 50.9 millimeter, and also it's going to be downward. So that is going to be the maximum deflection that we have from this calculation. And what we have from this is beam with special section that's changed with the portion of the beam. And we have the slope at the support A is going to be 10.02 10 minus 3 radian, and the direction of this is going to be something like this. Okay, and also you have the deflection of 50.9, just put it there, 50.9 downward millimeter, that is 4.45 meter from B. So that is the example, and you may have some understand on what we have to show for the beam with different eye, and the real application is about strengthening the beam. It's called strengthening beam by reduce the Vmax by reinforcing the steel plate at the middle portion of the beam. And if you like, you may take this portion to be the eye, and you do the same calculation. It's going to be a lot easier, and then you will get for sure larger maximum deflection than here. Okay, that's the end of the example, and hope you to have a chance to practice this by redo everything by yourself after you understand what I'm doing here from the clips. Okay, have a good day. Bye bye.